Hello, welcome back to IO Code. Right here we have on our screen the second question. Because of the first part, we printed out the values of an array in the reverse order. So this is the exercise 2, and it says create a binary tree node class to represent nodes in a binary tree. Each node should have a value associated with it. Additionally, I would like you to provide values for each node up to the 10th level of the tree, considering the root node as the starting point of the hierarchy. So it has to be something like you have a binary tree, you have the root node. The root node is more like the parent, and that parent has two different children, and those two different children has their own two different children up to the depth of the 10th generation. So if you don't know what a binary tree is, there's no qualms, because I'll be explaining in detail what the binary tree is when we move over to the solution part. Then the second part of this exercise says, write a program to calculate the number of nodes in a binary tree. You are provided with a binary tree node class representing the nodes of the tree. Your task is to implement a function or method that traverses the entire tree and counts the total number of nodes present. So consider the root node as the starting point of the tree, and your solution should work for any binary tree, including one you created earlier. So when we implement the solution to this number 2 problem, we are going to count the total number of nodes that are in the 10th level of this binary tree that we created in the first place. So we'll be using two recursive subroutines to solve this problem, and then we test our problem with the main class. So I'll move over to the solution part of it, and as you can see, I stated earlier, if you don't know what a binary tree is, I'm trying my possible best to use this little test to explain it for you. So a binary tree is a type of hierarchy data structure in computer science composed of nodes, where each node has at most two children, referred to as the left child and the right child. A binary tree is characterized by the following property. So I skipped this particular first part, this node structure, because the definition right here didn't really portray a binary tree. The reason for that, if I read through, you see each node in a binary tree contains a data element and two references or pointer to its left and right children, which is subtrees. The left child represents the node that comes before the current node, and the right child represents the node that comes after the current node. So this is more like a definition for a linked list, a kind of linked list that is linked both back and forward. So this is not a real definition for a binary tree node. Now this parent-child relationship is also how a binary tree node operates. Nodes in a binary tree are connected through parent-child relationships. A parent node has reference to its left and right children, whereas a child node has reference to its parent node. However, the root node of the tree does not have a parent. So it's only the root node that does not really have a parent in the whole of the tree. So the root node is at the very top of the chain. So we have tree topology, and it's basically what we explain this to. You can go ahead and read it. Then ordering has to do with in a case where you have binary sort trees. So there are some collections in Java that makes use of this sort tree. For instance, tree map is an example of such collections. And I put it, tree map is an example of such collection. Let me put it like that. Though it's not literally a collection because it does not extend the collection interface. But what I'm trying to say is you have lists, you have sets. So tree map is one of these data structures that takes the kind of ordering that this particular part is talking about. So we'll move over to the solution. Before we really get to the main algorithm solution, we have a diagrammatic representation. So we have a diagrammatic representation of a binary tree. As you can see, like I stated earlier, the first node does not have a parent node. It's known as a root node. However, it has on the left child and it also has the right child. As you can see now, this right child also has the left child and this right child, sorry, and even the left child has their own different right child and left child alongside associated with them. So our own task right here is to write a subroutine that is going to create a depth like this that goes all the way down to the tenth level. So let us see the solution to the algorithm. Now I say define a class that represents the binary tree object. Assign a fit variable of type node to the class. Create a node class that is used to declare a node object. So I guess this should come before this, but nevertheless we are going to fix it in the code. Now it says define two variables to represent the left child and the right child in the node class. So we'll create a method that is used to create the children of the node called create children. This can also be done with the constructor, but I prefer I just decide to create a method in the algorithm. I feel that will be much more better. And using the node object that is passed as parameter, we create two different node objects and assign them to the children node. So this particular part is part of is only the logic that will be implementing in the create children method, because that is you just have to do with two different assignment statements, giving values to the initializing the two different children. So we then go on further to say create a method called create generation that is used to create any number of generation of node for a binary tree object. So this create generation method, this is the algorithm to follow. The method takes into parameter. First parameter is the number of generation you are planning to create. You can switch them. The second parameter is the nodes to create the generation for. Now it says if the number of generation equals 0, you return from the method. So this is our base case. If the number of generation to create is equal to 0, we return from the method. Now we call the create children method passing the required node as parameter. So when we pass the node to the create generation method and it is not equal to 0, then we'll call the create children method to create the children of that node, and then we reduce the number of generation by 1 and call create generation for the two children node. So basically, after the first top root node, we call the second generation, that's both the left child and the right child. We call the create generation. We call create generation method for this two node. Then we reduce the generation by 1. So you are going to see it in action right now. I've written the code already. All I just have to do is open my IntelliJ and give you a little explanation of how the code is being implemented. So like I stated, I've written the code and I've also run the code. So this is a node class that represents a node object, and I in fact defined a global variable node object right here. So when we create an object of binary tree node, we are going to have this a reference to this node object. That means we can access the node object. So this is the left node and the right node. That's the children node of this particular node object. So this node right here has reference to the left node and the right node, because we have defined a static class inside of our main class that is used to represent these two nodes. Now we have the create children method, and this create children method is going to create the left node and the right node. It's going to initialize them with a new keyword, so they point to an object at this point. The method takes in a node object. You can also define this create children node inside of the node class, but I decided to take it outside. So that is what I did. Now we have the create generation method from our algorithm. This method takes in two variables. What is stated was the generation context and the node you are making the generation for comes second. However, I interswitched it, doesn't really matter, it's the same thing. Now we are going to check for the base case. If the generation is equal to 0, we return from the subroutine. Now, if this part turns out to be false, it moves over to the normal control program. So we call the create children of the node that was passed into the subroutine, and then after we call the create children method, I decided to add a printf statement where we can go out. You don't really need the printf statement. I just wanted to indicate that okay, the creation of the particular generation has started. Now we go on to reduce the number of generation. So this statement right here is going to reduce the number of generation. Then we then create generation for our left node and pass in the value of generation. So initially, when the value of generation is 10 right here, because we are starting with the root node, it's first of all create the children node, and then when it has created the children node, it's going to go on and subtract 1 from the generation, and then it will call the create generation for the left child node and the right child node, and then also pass the value of generation. So the root node is the 10th hierarchy. The next two nodes after the root node is going to be like the 9th hierarchy. So the generation for those two different nodes is going to be 9, since in this case we are using a value of 10. So you can decide to as well pass any integer value of your choice to this create generation method and create as much generation as possible that you have chosen. Create as much children node. And in real life scenario, this node object is going to have more like a feed, but I didn't include a feed. When I say a feed, it's going to have like a particular variable type it is referring to. It might be string, variable, might be names, might be an int type, int id, or any other thing that might be associated with so that's what a node is typically used for, but I didn't include those other parts in this video. Probably I'll make a video that has a node that represents a string type or an int type in the future, but now I didn't do that, I didn't implement such, so let's just move on further. So right here we have our main method that is our starting point of the program, and then we created an object of the class type, which is binary tree node. We initialized it, we call the create generation, simple as that, and then we passed in the node object, the node attribute of the binary tree node, and then we passed in our specified generation. I used 11, and I can go as well and change it to include 10. So I run the program now. So you can see we've done it right here. Changes on the thing. So that is basically it. When it's finished, it says all 11 generation created. That's because this value right here was 11. I can change the generation just so that it will flow along properly. So we're saying generation equals to 10. Then anytime you can go ahead and even use the scanner that prompts you to input any number of generation you choose. So I'm going to pass the value of generation here, and right here I'll do the same thing. So that is basically it. So this is the end for this first part. In the next part, we'll be looking at how to count the number of nodes that was provided, perhaps that was created using this thing generation or any generation at all. So thanks for watching. If you are here to subscribe to this channel, please do so. It literally doesn't take anything. I'll be providing good content for you guys, and if you want to be a partaker of such, subscription to the channel will do you more good. Smash that bell icon, give me a thumbs up, and I'll catch you in the next one. Peace out.